Hello students, I hope all of you are doing well. So in this video, we will be revising all the concepts and formulas of motion in 2D, and we will keep a special focus on our projectile motion topic, right? So let us start. Yeah, so let us start. So what we have is all the topics that we'll be discussing in this video is, first of all, we will discuss about generally how we deal with motion in 2 dimension. Then we will focus on your projectile motion. In projectile motion, we will discuss ground to ground projectile, then projectile from height, and then projectile on incline. So let us start. First, when we are talking about motion in 2D, what do we understand by motion in 2D? Whenever a particle is moving along a curve path, when it is having a curvilinear path, we term it as having motion in 2D. How we deal with motion in 2D? Motion in 2D is dealt by breaking down the motion in two one-dimension motion. Basically, if let's suppose a particle is having a velocity of u, at this instant it has a velocity of u and it makes an angle of theta with horizontal, and it is moving along this curve path. Now this velocity u we can break down into two components. This will be your u cos theta and this will be your u sin theta, right? How we deal with motion in 2D? We break down motion into two one-dimension motion. So 2D motion is studied as two one-dimension motion, as two 1D motion. What do I mean by this further? Let us look at in detail. So if it has a velocity of u and it is moving along this curve path, so we will study them as x direction and y direction separately and then combine the results, keeping time as the common quantity, right? Keeping time as the common factor. So let us say that acceleration of this, let's consider that acceleration of this particle is given as ax I cap plus ay j cap. This is what is the acceleration, right? Now if again, as we said that we will consider them, we will break down into two one-dimension motion, x separately, y separately. So in x direction, if I have to write down, if I have to write down velocity at any time t, what will be our velocity in any time t in x direction? Vx will be ux plus ax into t. This is velocity at any time t. If we have to write down the position in x direction, that is position in x at any time t, what can we write? X is equals to uxt plus half axt square, right? Then in y direction, if we have to consider, in y direction velocity at time t, we can write as vy is equals to uy plus ayt, and displacement in y direction or position in y direction at any time t can be written as sy, or we can take it y is equals to uyt plus half ayt square. Okay, this is what we have got. Now this is how we deal with your motion in 2 dimension. Now many a times something known as your equation of trajectory is asked, right? What is equation of trajectory? Equation of trajectory is relation between position in y and x. Equation of trajectory is the relation between the position in y and position in x. This is your equation of trajectory. Now, how do we deal with equation of trajectory? If let's suppose we have to find equation of trajectory in a question. So how we deal with it? You know over here position in x, you know over here position in y. Over here we will solve these two equations and eliminate t, that is time. When we get relation between x and y, that will be our equation of trajectory, right? This is all about your motion in 2D. Now let us move ahead. Now, so we are done with it. Now let us move ahead and look at projectile motion in detail. Now projectile motion is 2-dimension motion only, it's 2D only. It is a special case of your 2D motion. So let us see it in detail. Yeah. So let us see projectile motion. First of all, we are looking at ground to ground projectile. What do we understand by projectile motion? Projectile motion, whenever a particle is thrown with a velocity u, at an angle theta with the ground, then it performs a 2D motion under the effect of gravity, and its path is a parabolic path. The path of the particle is parabolic path. This is what is your projectile motion, right? Now, there are some specific results that we need to keep in mind. There are some studies how we deal with it, how we deal with projectile motion. So as we mentioned earlier also, that any two-dimension motion, we will break them into two one-dimension motion, in x direction separately, in y direction separately. That means x direction and y direction 1D motion is studied independently. We are very good with dealing with your kinematics motion in 1D. So that is what we use over here, right? So let's see over here, this is the situation given to us. A particle is thrown with velocity u at an angle theta, and this theta is with horizontal taken, right? So first of all, let's look at the initial parameters. Initially, if we do the component, this velocity we can write as your u cos theta. Y direction component can be written as u sin theta. Let us find out your x direction parameters and y direction parameters. So in x direction, if we see, what is your initial velocity? Initial velocity in x direction is u cos theta. What is your acceleration in x direction? Now the thing is that there is no force acting in horizontal direction. Whenever a particle is thrown from ground, the force is acting mg in vertically downward direction. There is no force in horizontal direction. If no force, therefore in x direction acceleration is 0. If acceleration is 0, now if we have to write down velocity at time t, Vx will be your what? Because acceleration is 0, velocity remains constant. So Vx is always equals to ux, which is equals to, we can write down u cos theta into t, right? Sorry, u cos theta. And velocity in x direction is u cos theta. Now, if we have to write down the displacement or the distance traveled in x direction, what can we write down? Distance traveled in x direction will be velocity in x direction into time, because it is what type of motion in x direction? It is acceleration is 0. That means it is your uniform motion. Over here it is uniform motion in x direction. Constant velocity, uniform velocity is there in x direction. Fine. So distance traveled in x direction, we can write down distance will be velocity into time. What is our velocity? U cos theta. At any time t, if we have to find out, this will be u cos theta into t. Okay. Let us look in y direction. So this is in x direction. In y direction, what is our velocity? Initial velocity in y direction. Initial velocity in y direction is u sin theta. What is our acceleration in y direction? It is g. Acceleration in y direction is g, and it is downward, so minus g. At any time t, if we have to write down velocity, so vy will be uy minus gt. Uy value is u sin theta. Acceleration is your downward minus g. So v at any time t, velocity will be vy equals to uy minus gt. At any time t, if we have to write down displacement in y direction, if we have to write displacement in y direction, we can write y is equals to uy, which is your u sin theta t minus half gt square, right? Minus half gt square. Here also we can take it u sin theta. Okay. So this is what we got, velocity at any time t. This is your displacement in y direction at any time t. Next, if we have to write down, let's suppose that at any time t, we have to find what is the angle made by the particle with horizontal. So let's suppose that we consider a situation where the particle is moving like this, and it is making an angle of alpha. After time t, it makes an angle alpha. That means it is moving at an angle of alpha with horizontal. So over here, what you will get? You will be getting, this is Vx and this will be your Vy. So what can we write? Tan alpha. Tan alpha can be written as tan alpha, that is alpha is the angle at any time t with horizontal, will be Vy by Vx. How do we calculate Vy? We have seen over here. Vx always remains constant, which is u cos theta only, right? So this is how we deal with projectile motion at any time t. This is how we write velocity in x direction, which is always constant. This is how we write distance traveled in x direction at any time t. This is your velocity in y direction at time t. This is your displacement at any time t in y direction, right? Now let us move ahead. So till now we have discussed what is projectile, how to deal with projectile. So some of the result that we got is distance traveled in x direction we can write as u cos theta into t. Distance traveled in y direction we can write as u sin theta t minus half gt square. Okay, then your velocity in x direction, it is constant always, which is your u cos theta only. Velocity in y direction at time t, vy will be u sin theta minus gt. Okay, now there are three important physical quantities that we should keep in mind. What are these three physical quantities that we are telling, or three parameters that we are talking about? Over here we are talking about time of flight. Time of flight basically is the time for which particle is in air, or the time taken by particle to complete this journey. How much is the time? Time of flight is given as 2u sin theta by g. 2u sin theta by g is the time of flight. Now this is also written as t is equals to 2u perpendicular by g. 2u perpendicular by g. Now please see over here, this relation, many a times this relation is also helpful. Why I am saying this? In this case and most of the cases, this theta is taken with horizontal. Theta is taken with horizontal, but let's say a question is there where theta is taken with vertical, then this will not be your sin theta over here. If it is taken, if theta is taken with vertical, then vertical component will become u cos theta. So the time of flight will come in that case when theta is taken with vertical. In that case, time of flight will come 2u cos theta by g. Right? That is why this relation also should be kept in mind, as many a times it is helpful to us. So if it is with horizontal, which is most of the time, this is the case that we get. So time of flight is 2u sin theta by g. Next, if we take a look, we have got your time of flight. Next is h max, maximum height. This is our maximum height over here. H max. H max relation, what is our H max relation? H max is u square sin square theta by 2g. U sin theta is u perpendicular, therefore we can also write it as u perpendicular square by 2g. So this is your H max relation. Okay, next relation that we have is for range. What is our range? Range is basically the maximum horizontal distance traveled by the particle. Range is basically the maximum horizontal distance traveled by particle. So range we get, if we talk about range, so range R is u square sin 2 theta by g, which we can also write it as R is equals to 2 ux uy by g. 2 ux uy by g. Again I am saying keep this result also in mind. In some questions this is helpful, right? This some mathematically sin 2 theta is written as your 2 sin theta cos theta. Ultimately we will get it 2 ux uy by g. So this is our range relation, right? Important relation, they should be on your tips. Time of flight is 2u sin theta by g, which we can write as 2u perpendicular by g. H maximum height is u square sin square theta by 2g, which we can write as u perpendicular square by 2g, and range is u square sin 2 theta by g, which can be written as 2 ux uy by g. So these are the parameters that we should have in mind. Let us look ahead. So let us look at some more relations regarding projectile, or some more points that we need to keep in mind. The first point that I want to focus on is velocity at the topmost point. Over here at top point, what is our velocity? So velocity at top point, as we know that velocity remains constant in x direction. So over here x direction velocity will remain, which is u cos theta. But at top point velocity in y direction becomes 0. So at topmost point velocity is there, which is v is equals to u cos theta. V is equals to u cos theta. Second point that I want to discuss is about your maximum range. It is maximum range. Now what is our maximum range, or range? What we write it? Range is given as u square sin 2 theta by g. Maximum range, for maximum range, it is about at if a particle is thrown with a velocity of u, at what angle should it be thrown such that we get maximum range value. So for maximum range, theta value should be 45 degrees, and at theta 45 degrees we will get R max value. How much is our R max value? R max value comes out U square by G, because this will become sine 245, that is sine 90. So our R max value is U square by G. So at 45 degrees we get maximum range, and maximum range is your U square by G. Next point if we have to look at it is about complementary angles. What do I mean by that? Let's suppose that two particles are thrown with same velocity u but at an angle of theta 1 and theta 2 such that theta 1 plus theta 2 is 90. That means the angle of projection is complementary. So we have two particles, one is theta 1, second is theta 2. If two particles are thrown with same velocity but at different angle theta 1 and theta 2 such that theta 1 plus theta 2 is 90 degree, then they will have same range. That means over here, if I have to draw this one will be having this thing. The range of the two particles thrown with same velocity but at angle of projection which are complementary to each other, then the range will be same. That means R1 will be equals to R2. Keep this point in mind. Many a times it is very helpful, right? Questions are asked directly regarding this point. Next, one more relation that we can keep in mind is about relation between your height and range. Height, maximum height, what we got? Maximum height u square sine square theta by 2g. Your range, what we got? Range is our u square sine 2 theta by g. Now when we solve these two, height and range, the relation between height and range comes out to be h is equals to r tan theta by 4. R tan theta by 4. So this is a result you can keep in mind. Many a times it is very helpful, right? So these are some points regarding projectile from ground to ground. Let us move ahead. Next thing we'll see. So let us see. The last thing that we have to see about projectile, ground to ground projectile, is trajectory equation. Trajectory equation. Trajectory equation is basically the equation of the path which particle is following, which is basically your relation between x and y. Relation between x and y. X is the position or displacement in x direction, y is the position displacement in y direction. How we give it? At any time t, x is u cos theta into t, y is u sin theta t minus half gt square. So relation between x and y is calculated, or we find out the equation by solving this x and y relation. Basically t over here can be written as what? T can be written as x by u cos theta. When this x by u cos theta is substituted over here, the relation that we get is y is equals to x tan theta minus gx square by 2u square cos square theta. 2u square cos square theta. This is the relation. This is your trajectory equation. In one more form we should keep it in mind. What is that? So we have y is equals to x tan theta minus x square tan theta by r. Now these are our trajectory equation, that is relation between x and y, that we should keep in mind. What type of questions are asked? The basic questions that are asked is about, let's say a quadratic equation is given to you. A quadratic equation is given, y is equals to ax minus bx square, and it is said that this is a trajectory equation of a projectile. So what we need to do is we need to compare this quadratic equation with the trajectory equation that we know, right? Over here, as you can see, the coefficient of x is tan theta, here coefficient of x is a, and coefficient of x square is b, so coefficient of x square is tan theta by r. Using this we can calculate your angle of projection theta. Using this we can calculate the range. So if I show, let's suppose this is what is given to us. So if we compare, tan theta will be equals to what? A. Therefore angle of projection theta will be tan inverse of a. Next, over here coefficient of x square is b. So what do we get? So tan theta by r is equals to b. Therefore what can we write? Range, from this range will be your tan theta by b, and tan theta is a. So range is equals to A by B. You can keep this also in mind if a quadratic is given to you. Directly range can be written as A by B. A is coefficient of x and B is coefficient of x square, right? So many a times you will be getting this type of question. I hope you can deal with it, right? So this is it. This is about your ground to ground projectile. We have done with ground to ground projectile. Next we will look at your projectile from height. Let us look at it. So let us see. The next thing that we are discussing is projectile from height. Now projectile from height, what we are talking about? Let's say that a particle is thrown from a height h. A particle is thrown from height h. Over here we'll see different cases. The first case that we are talking about is that it is thrown horizontally. It is thrown horizontally. Sometimes it is also termed as horizontal projectile, right? So what do we mean by that? So let's say a particle is given a velocity u horizontally, right? So let us do analysis. What type of motion will be there? What type of path it will take? So the path that it will be taking is, this is the path that the particle will be taking, right? This is the path that particle will take. It's a curve path. It's a motion in 2D. How we deal with motion in 2D? We study x direction separately and y direction separately. Now let us look at initial parameters. Initial parameters ux. Ux is u only. Acceleration in x direction. Acceleration in x direction is 0. Next, if we look at uy, that is initial velocity in y direction, it is thrown horizontally. So there is no velocity in y direction. Uy is 0. Acceleration in y direction, it is g, and to be precise minus g, because downward. Okay. In x direction, as you see, acceleration is 0. That means it is uniform motion. Whereas in y direction, there is a constant acceleration. Therefore, it is uniformly accelerated motion. So over here, constant velocity, this is uniform motion, whereas this is uniformly accelerated motion. It's a non-uniform motion, but acceleration is uniform. So uniformly accelerated motion. Okay. Next, let us look at some of the parameters that we need to know in horizontal projectile. First thing is, if we have to write down distance traveled in x direction. So what can we write distance traveled in x direction? X will be velocity in x, which is your u, into t. So at any time t, distance traveled in x direction can be written as x is equals to u into t. In y direction, if we have to write down distance traveled at time t, what can we write it? Y is equals to uy. It is 0 only. So y is equals to half gt square, right? Minus half gt square or half gt square in downward direction. This is it. Next, if we take a look at time, how much time at any time t, if we have to write down velocity, velocity in x direction will remain constant, which will be u only. Velocity in y direction we can write as uy minus gt. So it can be written as g into t. So the magnitude of velocity at time t will be gt, right? So let's say that at time t, this is the velocity u, and in y direction it is your gt at any time t. If we find out the angle, what can we write down? Let's say this is your resultant velocity coming, angle made with horizontal. So what can we write? Tan alpha will be Vy by Vx. Vy by Vx. This is your tan alpha. Vy value at any time t is gt, and Vx is constant, which is u. Now over here, we should know one result, which is about your range. The maximum distance traveled in horizontal. This we are talking about. Range. Maximum horizontal distance that it has traveled, right? Now range is basically your that is maximum horizontal distance, which is u into t. How much time it will take? The time taken by particle to fall down. Time taken by particle to fall down is your root over 2h by g. So this is our range in horizontal projectile, right? These are all the parameters related to your horizontal projectile. We need to keep range in our mind, this formula in our mind. Fine. Let us look at next thing. The next, I'll rub this part, range thing. Now, if we look at second case, which is if a particle is projected from height at some angle, what will change? So a particle is there which is thrown with velocity u at an angle, let's say theta, at an angle of theta. So this is we are talking about at some angle. So u at an angle of theta. Now, over here what will happen? Still horizontally it is uniform motion, vertically it is your uniformly accelerated motion. Everything remains same. The thing that has changed is that there is some initial velocity in y direction. So we can do over here component, this is your u cos theta and this is your u sin theta. And in y direction a initial velocity has come, which is u sin theta. In upward direction, because it is the angle is in upward. Now if we have to find out time taken by particle, so what will be the path? This will be the path of particle, right? Time taken by particle to come down, come on the ground. What can we write it? Displacement in y is equals to uy t minus half gt square. Using our this second equation in y direction, we can find out the time taken by particle to come down. What is our displacement in y direction? Height of the particle, height of the building, that is your minus h. Uy is your u sin theta into t minus half gt square. Using this equation, a quadratic will come. Using this equation, we will calculate your time. Using this equation, we can calculate time. Now, if they ask us the range in this case, if they ask us range can be written as what? Range will be velocity in x direction into time, which is your u cos theta into t. T will be calculated from our this equation, right? So this is all about your projectile from height. Let us look at the next topic, which is your projectile on incline. So let's move ahead. So last we are looking at your projectile on incline. Projectile on incline, we'll be looking at two cases. First, when a particle is thrown up the incline, and next is when the particle is thrown down the incline. So what situation we have is, we have taken an inclined plane having inclination angle beta, and a particle is thrown with a velocity of u at an angle of alpha, and this angle alpha is made with the inclined plane. This angle alpha is made with the inclined plane. Now how do we deal with it? First of all, the first thing that is done is that the coordinate system x and y, which we generally take it horizontal and vertical, is being, for this situation, is being changed such that x is taken along the incline and y is taken perpendicular to the incline. So the first thing that is done to study your projectile on incline is to consider the coordinate system. Along the incline we consider x direction, and perpendicular to incline we consider y direction. Now let us look at the initial parameters. If we see initial parameters, initial velocity is u. Along the incline, what will be our velocity? It will come out to be u cos alpha. Perpendicular to incline, we will get it u sin alpha. Okay. Next, if we talk about acceleration, we know that acceleration is g vertically downward. It is g vertically downward. So the component along the incline and perpendicular to incline, it will come out to be, this will be your g cos beta, and down the incline it will be g sin beta, right? Now interesting thing, over here x direction and y direction, both we are having acceleration. That means both are your accelerated motion. Now if we have to write down time of, that means the path will be something like this. If we have to write down the time of flight for this, using, first we will write down x direction equation, y direction equation, and time of flight for this is given as, time of flight is 2uy by acceleration in y. If you remember, initially we discussed 2u perpendicular in projectile, 2u perpendicular by g. From that only we are getting it. But over here acceleration is considered for the y direction. So 2uy by ay, what can we write? Uy is 2u sin alpha by ay. Ay value is g cos beta. Fine. Next, if we talk about maximum height, this, if we talk about the maximum height on the incline, maximum height will be uy square by 2ay. If we substitute the values, we will be getting u square sin square alpha by 2g cos beta. This is our maximum height that we'll get. Range, that if we have to calculate range, so how we'll calculate range? What will be a distance traveled in x direction? Distance traveled in x direction we can write as x is equals to, because it is your accelerated motion, so x is equals to uxt plus half ax t square. Let us substitute value. So using this we can find out your distance traveled in x direction. Now for range, I can write down range will be equals to r is equals to ux, that is your u cos alpha into time. Time is your this time of flight, minus of half acceleration in x. How much is our acceleration is x? G sine beta. So minus G sine beta into capital T square. Using this, we can find out our range also, right? So please remember these results. These are the results that we have to keep in mind. And using this, we can calculate range if they ask range in case of your projectile on incline. Now, next, let us look at down the incline situation. So, we are talking about your down the incline situation. That is when a particle is thrown at an angle of alpha with the inclination having and inclined plane is having an angle of beta. So in this case, if we look at the time of flight, maximum height and the range, so what will be the path? The path of the particle will be something like this. This will be the path of particle. In this case, your x and y, first of all, let us look at all the parameters, initial parameters. This will be down the incline, it will be u cos alpha, perpendicular to the incline, it is u sin alpha. Then acceleration, we know acceleration will be g cos beta, and this one will be your g sin beta. Now, time of flight, time taken to complete the journey, time of flight is given as 2uy by ay. Uy, how much is uy? U sin alpha. U sin alpha by ay. Acceleration in y direction is g cos beta. G cos beta. Next, if we have to consider the height, maximum height, this is what we are talking about, h. So h max is uy square by 2ay. So we can write down u square sin square alpha by 2g cos beta. This will be our maximum height. If we have to find out distance traveled in x direction, because with that only we will get our range, with that only we will be getting our range, the maximum horizontal or maximum distance traveled, right? So x, what can we write down? X can be written as uxt plus half axt square, plus half axt square. If we say this is our x we have taken, this is our y we have taken, what can we write? X is, that is the maximum distance, that is range. Ux value is u cos alpha into, for total time it will be time of flight, plus half ax value is g sin beta into t square. Right? With this we can write down our relation. Now over here, one way is you mug up all the relation, or you remember these results. You remember these results, how we are writing these results, and then whenever if question is asked, you can write down the result and you will get your relations very quickly, right? So with this we have completed our projectile revision. I hope you found the video helpful. If you liked it, do consider to press the like button and subscribe to the channel. Thank you very much. Bye bye.